In this video, I'll show how to do a few of the problems from the average rate of change, instantaneous rate of change worksheet. So problem number 4, part B. Several people had questions on that one. And so to find the instantaneous rate of change, we need to do the limit as h approaches 0 of f of 2 plus h minus f of 2 divided by h. And that is the limit as h approaches 0 of 1 over 2 plus h, because the function is f of x equals 1 over x. So whatever's in parentheses, we put down in the denominator. So here I have 2 plus h in parentheses, so I put 2 plus h in the denominator, minus f of 2. So since I have 2 in parentheses, I put 2 in the denominator. Okay, and now we need to evaluate that limit. And I'll do that by getting rid of the complex fractions. And so back when we were studying complex fractions, we learned that you can get rid of the complex fractions by multiplying by the common denominator that you see in all the top and the bottom. So I'm multiplying the top and the bottom both by 2 and 2 plus h, because those are the two denominators that I see. So when I distribute here, I get the limit as h approaches 0 of 2. Here the 2's cancel, so I get minus 2 plus h over 2h 2 plus h. So here 2 minus 2 becomes 0, minus h, so we just get negative h on top, and 2h 2 plus h in the bottom. These h's cancel, leaving us with just a 1 on the top. And so that is negative 1 over 2 plus h. And h is approaching 0, so we just end up with negative 1/4. So the instantaneous rate of change of this curve at x equals 2 is negative 1/4. A few of you also asked about problem number 6, the last 3, D, E, and F. So each of these has their own unique tricks at work. So first thing we want to do, for example, D, the fact that there's a plus here, that doesn't really change anything. We're still trying to evaluate this limit, and so when we plug in 3, the denominator is 0, and so that means there must be a common factor or some way we can simplify that expression. And so here we have the limit as x approaches 3 from the right of 2 times x plus 3, and the denominator is x plus 3, x minus 3. And so these both cancel. And so now we just have 2 over x minus 3. And here's where the plus is going to make a difference, because we need to realize that when we're approaching 3 from the right, we're talking about numbers that are a little bit bigger than 3, like 3.1 or 3.01 or 3.001. Those are numbers that are a little bit to the right. And that makes a difference for this problem, because we know the denominator is getting really small. So this is going to either approach infinity or negative infinity. But since our x values are all bigger than 3, this expression is going to be positive. So that makes it approach positive infinity. If this had been the limit as x approaches 3 from the left of 2 over x minus 3, the answer would be negative infinity, because numbers that are a little bit to the left of 3, like 2.99, if I do 2.99 minus 3, that would turn out to be negative 0.01. And so as the denominator gets smaller and divides into 2 more and more times, it's going to be a really big number, but it's going to be always negative, because if we take a number less than 3 and subtract 3, we're going to get a negative answer. And so that's where the plus does make a difference. Okay, and then we'll do the same kind of thing with problem E, it's approaching 4 from the left, but when I plug in 4, the denominator is 0. So we want to try to figure out how we can rewrite this. So one nice trick that usually works when you have radicals is to try multiplying by that radical on the top, the conjugate on the top and the bottom. So it was root x minus 2, so I'm going to multiply by root x plus 2 on the top and the bottom. So then that becomes the limit as x approaches 4 from the left of x minus 4 over x minus 4 root x plus 2. And now we see the x minus 4's cancel. So we have the limit as x approaches 4 from the left of (1 over square root of x plus 2. Okay, and as x gets really close to 4, it doesn't really matter if it's a little bit above 4 or a little bit below 4 for this problem. The square root of a number getting close to 4 is going to be very close to 2. So this is going to be 1 over 2 plus 2, which is positive 1/4. And then for the last problem, we can try the same trick. If you try plugging in 9, you'll get a 0 in the denominator. But if we multiply by root x plus 3 on the top and the bottom, then we end up with the limit as x approaches 9, x minus 9 over root x plus 3. In the denominator, we have x minus 9. The x minus 9's cancel. So now we get the limit as x approaches 9 from the right of just root x plus 3. And as we get close to 9, this part gets close to 3. So it just becomes 3 plus 3, or 6.